Good evening, class. We are looking at Calculus 1 Exam 2 review, Chapter 3 Differentiation Rules, which covers from 3.1 to 3.8. And now over here, we're going to cover 3.4, the chain rule, 3.5, implicit differentiation. So how would you differentiate composite functions such as y equals the square root of 10x plus 5, f of x equals 10x squared minus 1 to the power of 50? Use the chain rule. If g is differentiable at x and f is differentiable at g of x, then the composite function f of g of x is differentiable at x. ddx of f of g of x is f prime of g of x, g prime of x. Please understand ddx is the operation of differentiation. In Leibniz's notation, if y is a function of u and u is a function of x, then dy dx is dy du dx. In other words, if capital F of x represents the composite function f of g of x, then capital F prime, which is the derivative of that, is f prime of g of x times g prime of x, meaning you differentiate the shell function. See, the main function is the outer function, the shell function. You differentiate that and then multiply by the derivative of the inside. As far as the general or the extended power rule is concerned, you know the derivative of x to the power of n is n x to the power of n minus 1. Now, the derivative of g of x to the power of n, which is known as the general or extended power rule, works in the same manner, meaning this one is being raised to the power of n, so we need the n. Then x to the power of n minus 1, we need g of x to the power of n minus 1. Over here, the derivative of x is 1, and we don't have to write it because times 1 makes no difference. But over here, it does make a difference, and we have to write it. Now, one set of example that will help us with this concept is involving signs. For example, sine 2x. The way I would differentiate those, I'm going to read sine and I'm going to pause. So, as you know, the derivative of sine is cosine. And I'm going to pause again. But every trigonometric function, every sinusoidal function must have an argument, otherwise it's meaningless. So cosine by itself is meaningless. So you have to use the same argument, namely 2x. Also, the chain rule says you need to multiply by its derivative, which is 2, and you put the 2 in front, and you say y prime is 2 cosine 2x. We're going to do the same thing for this one. Y equals sine, so the answer is cosine. Again, it's meaningless without its argument. So we need the same argument by the chain rule. We need the derivative of that, which is 2x, and we put that in front. So y prime is 2x cosine x squared. This one, I'm going to write it as sine x to the second power so everybody can see you're using the extended power rule. So y prime is a 2 sine x to the power of 2 minus 1, and then the derivative of the inside, we're talking about g prime here, and it's 2 sine x cosine x, and some of you may recognize this as sine. You don't have to change this, but you may recognize it as sine of 2a. In this case, 2x. It's the sine of double angle. So that's the concept of the chain rule. Let's look at a couple of examples here. And it's a warm-up example again, where y is a function of u to the power of 5, and u is a function of x, 10x cubed plus 2. I'm going to show you both ways, Leibniz's notation as well as composite function. And because it's simple enough, you can do both ways. It really makes no difference. However, the more complicated the question, you may have to go with the Leibniz's notation. So according to Leibniz's notation, dy dx is dy du du dx. Let's see what that means. This part means take the derivative of this expression with respect to u. U is the independent variable. And following the power rule, this is 5 u to the power of 4. Du dx, that means take the derivative of this expression with respect to the independent variable x. And again, the power rule 10 times 3, 30x squared. So this is 30x squared. We replace the u with 10x cubed plus 2. We write what we have, the product of these two, 150x squared sits in front, and we are done. This is using dy dx is dy du times du dx. Again, if you treat this as a fraction, these two cancel each other, you get the same thing, but it's still not a fraction. Composite function, f of g is f of g of x, therefore y prime is f prime of g of x times g prime of x, okay? And in this case, u to the power of a 5 means a 10x cubed plus 2 to the power of 5. So you can easily calculate the composite function. It's not always the case. So using this composite function, okay, dy dx or y prime is a 5 times, so the exponent becomes a coefficient, times this function g of x, 10x cubed plus 2 to the power of 5 minus 1, which makes it 4, times the derivative of the inside, which is 30x squared. And you put these two together and you get 150x squared times 10x cubed plus 2 to the power of 4, which is identical to what we have here. We're going to differentiate y equals 4 over the square root of x squared plus 3. Generally speaking, when you have a fractional format where the numerator is just a number, you don't have to use the quotient rule. You know this is x squared plus 3 to the power of 1/2, right, everybody? Look at this one. And then it comes up, becomes negative 1/2. I'm assuming nobody has any problem with the algebra behind this. So one more time. This is the same thing to the power of 1/2, comes up, becomes negative, and now we are going to use the extended power rule and differentiate that. So y prime, number 4 doesn't go away, it just remains. Then n is negative 1/2. Then g of x to the power of n minus 1, the same thing to the power of n minus 1. Subtract 1 From -1/2, you get -3/2. Let me make sure we understand this. So this -1 gives you this one. So we are here, and now G prime, the derivative of the inside, that's the meaning of it, which is 2x. Now, let me put an asterisk next to it to emphasize the importance of calculus, which is only one step. Everything else is algebra. This was algebra, and we're going to finish it with algebra. So first and foremost, 4 times -1/2, -2 times 2 is -4x. And you repeat this. Now, this goes down to the power of +3/2 and becomes the square root of x squared plus 3 to the power of 3 under the radical. I hope no one has any problem from here to here, okay? And so on. Y equals cosine 3t to the power of. First, let me explain what I have for you. The derivative of sine is cosine. The derivative of cosine is negative sine. If it's sine of u, the derivative of sine of u is cosine u du dx. See, it says d dx. That means x is the independent variable, which means the derivative of sine of gx is cosine of gx times g prime of x. This is by the chain rule. D dx of cosine u is negative sine u du dx. D dx of cosine of g of x is minus sine of g of x, g prime of x. In order for you not to make a mistake, just read cosine and stop. Cosine, pause. The answer is negative sine. You cannot write any trigonometric functions without its argument. So you use the same argument. By the chain rule, you tag along the derivative of the argument, 12t cubed, and put that in front, and you're done. So we are looking at this one, of course, d dt of cosine of g of t. So minus sine g of t, so minus sine, this is your g of t. So minus sine g of t, or 3t to the power 4, and then g prime of t. And that is 12t cubed. Again, in my opinion, the best course of action is to read cosine and pause, write negative sign, then carry the argument, and of course its derivative. That will be the easiest way to see the answer. When I differentiate y equals x squared plus 4x over x to the power of 6. We use our algebraic techniques and we recognize this as x and this as 4. In other words, make up two fractions first. Always look for the easy way out. This is x, this is 4. You don't have to use the quotient rule, and what we do is to use the extended power rule, 6. So I want to differentiate this. Y prime is the n, which is 6, times g of x to the power of n minus 1, the same thing to the power of 5. G prime is the derivative of the inside, although it's one, but I recommend you write it because sometimes it's not, and you're done. Y equals 2x plus 3 over x minus 8 to the power of 5. We are going to use the extended power rule as well as the quotient rule. So according to the extended power rule, and by the way, you always look at the fraction, ask yourself, can I simplify it? In this case, the answer is no. So first n or 5, then the same function, the parentheses to the power of n minus 1, 4. Then g prime, the derivative of the inside requires the use of the quotient rule. I'm going to write f over g, and I'm going to use that, which means f prime 2 times gx minus 8 minus g prime, the derivative of the bottom is 1, times the top, g prime f, 1 times 2x plus 3, over g squared, x minus 8 squared. And again, notice this is the only calculus step and it's done. Now, of course, we continue finishing it off using algebraic techniques. So we are going to simplify this last fraction, 2x minus 16 minus 2x minus 3. These two cancel each other, these two add up to negative 19. If you see the final answer and the last step, that's fine. If not, you can do it in 2 steps. I want to make sure that you see that this one is x plus 3 to the power of 4, x minus 8 to the power of 4. And the reason I separate them because I want to make sure we don't make a mistake. So what happens is that this stuff is in the numerator, 5 times negative 19, which is negative 95, to x plus 3 to the power of 4. This one is x minus 8 to the power of 4 plus 2. That would be the number. The derivative of e to the power of x is e to the power of x. And we know the composite function, the derivative of f of g of x is f prime of g of x times g prime of x. We are interested in differentiating the following functions, and they're all exponential functions. So if you happen to have e to the power of g of x, the answer is e to the power of g of x times g prime by the chain rule. So if it happened to be e to the power of kx is e to the power of kx times k, and you put the k in front. So when I want to differentiate exponential functions, I just write them immediately without any changes. Then the exponent is a t or x, I'm done. If it's not, by the chain rule, I need its derivative. I put that in front, and I'm done. Part B, I do the same thing. I see an exponential, I write it immediately. Then I look at the exponent, and I need the derivative of the exponent, which is secant squared. Part C, I want you to notice this means two-thirds x, and most everybody does, just in case I'm going to rewrite it. So Therefore, the answer is itself times the derivative of the exponent is simply 2/3. We put that in front and we are done. Y equals 2x squared plus 9x plus 9 over x plus 3. We want to differentiate this. Anytime you have a fractional format, in this case, more specifically, is a rational function, you ask yourself, can I simplify? Can I put it in its lowest term? And in this case, the answer is yes. 2 is a prime number. So basically, it's x and 2x. 9 is only 1 times 9, 3 times 3. You have to figure out what you need. And with the trial and error, you can get the answer x plus 3, 2x plus 3 over x plus 3. Here's what helps understanding this, and we're going to cross this. If this is supposed to be simplified, must have a factor of x plus 3. So if I'm working on this, I try with the factor of x plus 3, because if it doesn't have that factor, it can't be simplified. So I try it with x plus 3. And of course, 2x plus 3, its derivative is simply 2. We want to take the derivative of y equals 3 to the power of x, and we don't know how to do that because everything we've dealt with so far had a base e. We know the derivative of e to the power of x is itself, e to the power of kx is itself times k, e to the power of g of x is itself times g prime. So what is the derivative of something with a different base? For example, b to the power of x. In that case, I'm going to remind you of logarithmic properties. You know, ln of e to the power of x is x, e to the power of ln x is x, because the two functions are inverse of each other. So every number x can be represented by e to the power of ln x, and that's exactly what we are going to do to b. We're going to represent it with e to the power of ln b, because when the base is e, we know how to deal with it. So we write that. And that means e to the power of ln b times x. Please understand, ln b is a number. This is precisely like e to the power of kx. ln b is like k. So what is the derivative? The same thing times k, or ln b. We also know e to the power of ln b can go back to the same format b. So we are going to change this one to b, and it's b to the power of x. Times ln b. Therefore, what is the derivative here? The moment you see exponential, write it itself. Two things you have to look at. Is the base e? No. Then you need ln b. You need ln 3. What about the exponent? The exponent is x. We are done. Okay. What about y equals 2 to the power of 7x? In addition to what we have seen, we also have the chain rule. So if y is b to the power of x, f of x, y prime is b to the power of f of x times ln b. And then because of the chain rule, f prime. So the answer is itself. The base is not e times ln 2. The exponent is not x or t or theta. Its derivative is 7. Put them together. And the reason I'm putting this inside the parentheses because I don't want anybody to think this is ln of 22 to the power of 7x. Okay, so the way you write it is important. Applications. Observations show that the length in millimeters from nose to tail of a Siberian tiger can be estimated by the function L equals 0.25 W to the power of 2.6, where W is the weight of the tiger in kilograms. Furthermore, a young tiger's weight can be estimated in terms of its age t in days by the function W equals 3 plus 0.21 t. How long is a tiger when it's 100 days old? This part is elementary algebra. Needless to say, what they are interested in is finding the L. You can find the composite function, but I want to show you two different ways. Number one, just plug in 100, and this is elementary algebra class. This, of course, has two decimals, two zeros cancel each other. That becomes 21 with 24 kilograms. Now, what is the length? Put the weight into this function. 0.25 times 24 to the power of 2.6 is 969.369 millimeters. You put it into a calculator, okay, class? And some of you may remember that 1 meter is about 1,000. It's 100 centimeters or 100 millimeters. So it's almost, this is almost 1 meter. So this is elementary algebra. At what rate is the length increasing when it's 100 days old? Or they can even say changing, and then positive means increasing, negative means decreasing. There is this word rate and one point in time that definitely gives you differentiation. So at what rate is the length increasing when it's 100 days old? So one dl dt. First, I want to discuss the Leibniz's notation. dy dt is dy du du dt. What is u? The intermediate variable that takes us from y to t. So dl dt, I'm going to write it in the same fashion, and I'm not going to put anything here yet, just like this one, the dl dt. And again, y is the dl dt. At what rate the length is changing when it's 100 days old, so dl dt. So what variable takes us from L to T? The intermediate variable is W, so you put dW. That's how you find this du, or in this case, dW. So now that we have that, we want to differentiate this dl dw. That means differentiate this with respect to W using the power rule. 0.25 times 2.6 times W to the power of 2.6 minus 1, which is 1.6. In other words, this part is this, everybody. What about dw dt? That means take the derivative of this function with respect to t, which gives you just 0.21. If you multiply 0.25, 2.6, and 0.21, you get 0.1365 W. And notice you could change the W to this and make it a function of it. However, since we just want the rate when it's 100 days old, and we know when it's 100 days old is 24 kilograms, we can replace the W with 24, put it into a calculator, and we get 22.0532 millimeters per day. The units of the length over the units of the time. So very straightforward, everybody. Method 2 is that write L as a function of t by replacing this into W. Just replace the W. Okay, so put this here. Now, of course, if I replace the t with 100, everybody, 0.25 times 3 plus 0.21 times 100 to the power of 2.6, I must get the same answer as I had here. And I do. So in this case, you recognize that finding the composite function wasn't too difficult. If it is, you have to go that route. In some instances, this is easier class. The second part, the LDT or L prime of t. How do we differentiate this? The extended power rule. So 0.25 remains times 2.6 times the same thing to the power of 2.6 minus 1, which is 1.6, times the derivative of the inside, which is 0.21. Let's recap. We are differentiating this. 0.25 remains. 2.6 becomes the coefficient. The parentheses to the power of 2.6 minus 1 becomes 1.6. By the chain rule, you need the derivative of the parentheses, which is just 0.20. If you multiply these three numbers, again, you get 1.365. And notice, right here, if we change the W to 3 plus 0.21t, we would have gotten that. And now if you plug in 100, it will give you the same answer as here. So I hope it's clear to everybody. Two different ways. Using Leibniz's notation, finding the composite function and working on that. The amount of glass recycled in a community is given as G of P equals square root of 0.5 P squared plus 7 tons, where P is the population in thousands. It is estimated that 10 years from now, the population of the community will be P of T equals 4.4 plus 0.1 T squared. Thousands. How many tons of glass are expected to be recycled 4 years from now? This is pretty similar to the previous one. We can go just the way it is, or we can find the composite function. This is an example that finding the composite function makes things a little bit more difficult, not impossible. So the moment you hear 4, you put it into t, and that gives you 4.4 plus 0.1 times 4 squared. 4 squared is 16, times 0.1 is 1.6. They add up to 6,000 people. Now you put this in here to find the amount of glass in tons. You notice 6 squared is 36. 0.5 times that is 18. Plus 7 is 25. Take a root is 5 tons of glass. So this is elementary algebra class. You just plug in and you observe. And now calculus. Find the rate at which the amount of glass recycled is changing with respect to time 4 years from now. Again, the moment you see rate and one point in time, that means differentiate. So what are you differentiating? Let's find out. Find the rate at which the amount of glass is changing with respect to time, dg dt, or g prime of t. dg dt. So we're going to write it in Leibniz's notation. dy dt is dy du du dt. And what goes in between? G goes to t. What is the intermediate variable that takes us from G to T? Is the P. So dg dp, dp dt. What does this mean? Take the derivative of a g with respect to p. What does this mean? Take the derivative of p with respect to t. That's the meaning of it. So for dg dp, we have to differentiate this piece, and to do so, we are going to rewrite this to the power of 1/2. We take it out, so we make it ready for the extended power. And so this part becomes 1/2 times the same thing to the power of 1/2 minus 1 or negative 1/2 times the derivative of the inside 0.5 times 2p, which is p. Let's recap. I want to differentiate this. 1/2 times the same thing to the power of 1/2 minus 1 times the derivative of the inside, which is 0.5 times 2p, which makes it p. Okay. What about this one? dp dt now times the derivative of this piece. This is nothing. 0.1 times 2t is 0.2t. And we have two choices. We can replace the p with this formula and use the t equals 4 because that's what they want. Or when t is 4, the previous one shows that the p is 6. So when t is 4, p is 6. First, let's simplify this. To simplify this, let me clean up. So you have a fraction bar. In the denominator, you have 2. This one goes to the denominator, becomes positive 1/2 and becomes a square root. At top, you have 1. You have p. You have 0.2t. So at top, you write 0.2 pt. The bottom is 2 times this one, which is looking like that now. Where p is 6, t is 4. So we're going to plug in. Let's replace the p with 6 here, t with 4, and this one, you remember right here, we get 5. If I replace the p with 5, with 6, I get 5. So because 6 squared is 36, half of that is 18, plus 7 is 25. Take a root. So this comes out as 5. So we know this is 5, and we plug in the rest of it. The product of those three is 4.8 divided by 10 gives you 0.48 tons of glass per year. What does it mean? 4 years from now, the amount of glass recycled is increasing. Why increasing? Because this is positive at a rate of 0.48 tons of glass per year. If it's negative, you write exactly the same thing. You change the increasing to decreasing. Now, for this one class, we can replace the p with 4.4 plus 0.1 t squared. That makes g a function of t. This is, in essence, the composite function of the two functions. And this, believe it or not, it's a little bit more difficult to work with, especially when it comes to the second part. Part A is not a big deal. But for differentiation, it's easier to go with the Leibniz's notation. So those are some applications. Differentiate y is cosine to the power of 10 of sine x cubed. And to differentiate this, I'm going to rewrite this because I want everybody to see that we have cosine to the power of 10. Doesn't matter what this is. You can call it g of x or anything you want to call it. Cosine to the power of 10. And that's the idea that I want everybody to see. Cosine to the power of 10. So we are going to use the extended power rule. So we need 10 cosine to the power of 9. 10 cosine to the power of 9. And of course, cosine to the power of 9 of what? Same argument, g, sine x cubed. So if it helps, you can say g first, or g of x. Literally change it to g of x. Now we need to take the derivative of g of x, everybody. So we need g prime of x. We need the derivative of sine x cubed. So in fact, I'm going to write it up here so you can see that in this case, in this context, we are saying g of x is sine of x cubed, and now we have to differentiate this and put it here. So how do you differentiate this? Differentiate the sine. You differentiate the cosine and then the sine. To differentiate the sine, we are talking about g prime of x here, okay? The derivative of the inside. So this is g of x, and actually let's just call this capital G of x. So the derivative of cosine is a negative sine. So the derivative of cosine is negative sine. But negative sine of what? The same argument. That means negative sine of sine x cubed. So this is, let me use it. That green is fine. Capital G prime of x in essence. But it's not finished because now you have to differentiate sine of x cubed, lowercase g of x, which means the derivative of sine x cubed is needed. So we need the derivative of sine x cubed. So again, you look at sine and you stop, you pause. Sine gives you cosine. Cosine of what? X cubed. And then finally x cubed, 3x squared. Let's recap. And we are going to rewrite this in a moment. What we are dealing with is something to the power of 10. G of x, I'm going to call this capital G of x. Capital G of x, the entire thing to the power of 10. So we need the extended power n, which is 10. G of x to the power of n minus 1. That means cosine of sine x cubed to the power of 9. That means cosine to the power of 9 of sine x cubed. And then capital G prime. Now, this one is capital G prime x. Let's see how that works. The derivative of cosine, so you read cosine and pause. The derivative of cosine is negative sine. You have to have the same argument. Then you have to have the derivative of the inside, because if you look at cosine u is minus sine u du dx. What is the derivative of sine x cubed? Cosine x cubed times 3x squared. You put all of them together by putting 3x squared next to 10. making it 30, and with this one, negative 30x squared. So first, I want to make sure we understand that this and this negative sign and this come to the front. Then, so we have negative 30x squared. Then cosine of x cubed, cosine to the power of 9, sine of sine x cubed. The rest of them, this part must be in front. It's really a good practice to put cosine x cubed also before the other two, because it's less complicated. If you didn't, it's not a big deal. These two, it doesn't matter. Both of them have the same argument, namely sine of x cubed. This is as nasty as it gets. If you follow that, you are really pretty comfortable with composite functions and their derivatives. I'm going to recap this one more time to make sure everybody's comfortable with that. First, you want to write it in this fashion because you need to recognize some function is being raised to the power of n, which is 10. And therefore, you are going to go with the x to the power. So first you put the 10, then you raise this one to the power of 9. So this is 10. This one to the power of 9 means cosine to the power of 9 sine of x cubed. Then you differentiate what's inside the brackets, cosine of sine x cubed. You can even do it on the side if you want. And how do you differentiate the cosine? Negative sign. And then sine of x cubed. And then the derivative of the inside by the chain rule is cosine x cubed times 3x squared. You put them together, and this is what you end up. We're going to differentiate x to the power of 4 times e to the power of 2x, and we are going to use the product rule. To do so, we're going to put a raised dot in between. And we're going to call this f times g. And use the product rule on that. Therefore, we are going to write f prime, which is 4 x cubed times g, which is e to the power of 2x, f prime g, plus g prime f. E to the power of 2x, the answer is itself because it's exponential. Then times the 2, the derivative of the exponent. And then g, which is x to the power of 4. In other words, we have f prime g plus g prime f. And we are going to factor what's in common. 4 and 2, 2 is in common, x cubed and x to the power 4 x cubed is in common, e to the power of 2x is common. I'm going to write, because class, this is the only calculus step. In fact, let me just erase my work so it becomes easier to see. I'm done with calculus. This is it. What I'm going to do is pure algebra, which means I need a common factor. 2x cubed e to the power of 2x. If you divide these two, everything goes away except 2. And if you divide this one by this one, everything goes away except x. And that's your final answer. Again, this is algebra, everybody. f of x is 9x times x minus 1 to the power of 4. It's the product of these two pieces. Again, since 9 is not involved, you can think of it as part of that, or you can put them in brackets. Either way makes no difference. So this piece, let's say f times g. So to take the derivative, so we are going to go with the product with f prime g plus g prime f. This gives us 9 times the second piece g, x minus 1 to the power of 4, plus. Now g prime, it uses the extended power rule. So we need 4. We need x minus 1 cubed. And then we need the derivative of the inside, which is just 1. And then finally the f function 9x, meaning if this is fg, everybody, this is f prime g, this is plus, this entire thing is g prime f. And as you can see, we are done with calculus. We are going to factor. What is in common? So again, let me actually put a asterisk next to it. I'm done with calculus, so I'm going to do algebra. 9 is in common. X minus 1 is in common. This has exponent 4. This has exponent 3. We choose the smaller of the two. Therefore, 9 times x minus 1 cubed is in common. So when you divide this one by this one, you're left with x minus 1. When you divide this one by this one, you get 4x. I hope you see it's a pure factory. So one more time. You divide these two, and you're just left with x minus 1 to the power of 1. When you divide this two, x minus 1 cubed goes away. 9 goes away. 4 remains. X remains 4x. And now you can combine these two into 5x. And the final answer would be 9x minus 1 cubed times 5x minus 1. All right, now y equals sine squared 8x. And we want to differentiate that. So we are going to rewrite this as sine of 8x to the second power first. Again, just to make sure we understand what we are dealing with. You don't have to write that. Just want to make sure that's fine. So something g of x to the power of 2, we are going with the extended power rule. 2 sits in front, sine 8x to the power of 1, or simply 2 sine 8x. And then you need the derivative of the sine 8x. Sine. That gives you cosine. Cosine of what? The same argument. And then its derivative is 8. And now 8 and 2, the product of those two, 16 sine 8x cosine 8x. That's the final answer. F of x is 3 times x times 3 to the power of x. So let's see how we deal with that. Obviously, it's using the product rule. Because if it is f times g. So first we need f prime, which is 3, times g, which is 3 to the power of x. And then we need the derivative of 3 to the power of x. And remember, any exponential, you just write the function itself. Then you look at the base. Since the base is not e, we need ln 3. Then you look at the exponent is it's x, you're done. So this is g prime, and now times f, which is 3x. And I'm going to write this at top of it so it becomes clear what we are dealing with here. We have f prime g plus g prime f, and we are done with calculus again. Right here with the asterisk, this is the calculus step. We're going to finish it off, of course. To do that, and to take a common factor, we take the following step. Number one, let me erase this so it becomes clear that this is 1. And so these two, they add up to 3 to the power of x plus 1. I'm using the product rule here. And this one and this one will do the same thing. So the first one is 3 to the power of x plus 1. The last one is 3 to the power of x plus 1 times ln 3 times x, which means 3 to the power of x plus 1 is in common. And if we take this out, this gives us 1, and this gives us ln 3 times x. You put the x in front because otherwise it's a little bit awkward. You don't want anybody to be under the assumption is ln of 3x. Implicit differentiation. So the question is, what is implicit differentiation? Function expressed by one variable or defined explicitly in terms of another variable, like y equals x squared minus 2x plus 1, or y equals f of x in general. Some functions are defined implicitly by a relation between x and y, such as x squared plus y squared equals 25, or x cubed plus y cubed equals 6x plus. In some cases, it is possible to solve such an equation for y, and in some cases, it is not easy or even impossible to do so. In such cases, we can use the method of implicit differentiation. This consists of differentiating both sides of the equation with respect to x, and then solving the resulting equation for y prime or dy dx. What do we mean by that? Let's start with the simplest example as a warm-up example where it can be done both ways. So when we say differentiate for x plus 2y equals 10, explicitly it means first solve for y. To solve for y, we are going to move the 4x and we make a negative on the right. Divide everything by 2. Y is negative 2x plus 5, and clearly y prime or dy dx is simply negative 2, and you're done. So that's solving for y explicitly. We've seen this before, but what is implicitly? We differentiate the way it's given, which means this one is 4, but what about y? The derivative of y is y prime or dy dx. Remember, y is like g of x, everybody. The derivative of g of x is g prime. So this gives you 2 dy dx or y prime, and 10 is a number, any number, the derivative is 0. On purpose, I put dy dx. I'm going to move the 4. I'm going to divide by 2. And dy dx is minus 2. Please understand they are both the same, y prime or dy dx. This is in Leibniz's notation telling us what is the independent variable. Specifically, when the independent variable is not x, we really want to go with that notation, for example, dy dt. Now, let's use implicit differentiation to differentiate 2x plus y to the power of 4 equals x minus 2y to find dy dx or y prime. We are going to differentiate on the left side. First, we need 4. Then we need 2x plus y cubed. Then we need the derivative of the inside by the chain rule, which means g prime of x. So if you think of this as g of x, you have to differentiate this. So this gives you 2 This gives you y prime or dy dx. Sometimes we use y prime. It's easier to deal with. It makes no difference, everybody. The right side is 1 minus 2 y prime or dy dx. And believe it or not, you're done with calculus here. This is it. I put the asterisk. Everything else, and there are several steps, is algebraic step to solve for y prime. Okay. And we are going to do that. So we are going to multiply this by 2. It becomes 8 times 2x plus y cubed. And then multiply this by y prime. So we write this one, we write this one, and we write y prime. Why am I doing it this way? Because I want to solve for y prime, and I want to isolate that. Therefore, what I'm going to do is to move this one to the right becomes negative, and this one to the left becomes positive. So again, notice this is not changing. This is now 2y prime, 1 minus that expression. So it should be pretty straightforward, everybody. We are going to factor the y prime out from the left side. And if we take the y prime out, it gives us the blue part and 2. What about the right side? We don't touch it. We just keep it unchanged. All we have to do to solve for y prime is to divide both sides by the brackets. So y prime or dy dx is the right side, 1 minus 8, parentheses 2x plus y quantity cubed, over the brackets here, 4 times 2x plus y quantity cubed plus 2. We're going to continue using its implicit differentiation to differentiate sine y plus 2x cubed y squared equals 6, dy dx, which is indicating the independent variable is x. So we're going to do it one by one. Sine gives us cosine, but it's sine u in essence, so you need du dx, so you need dy dx or y prime. And this one uses the product rule. We are going to say this is f, this is g, this is the product rule we are going to use on that part. To f prime times g. 2x cubed, the derivative is 6x squared, times g, which is y squared, plus g prime. What is the derivative of y squared? Is 2y prime. Everybody, take a look at this one. The derivative of g of x to the power of n is n g of x to the power of n minus 1 g prime. The derivative of y to the power of n, in the same manner, replace the g with y, and y to the power of n minus 1 y prime. And so we have 2y y prime or 2y dy dx times f, which is 2x cubed. Again, we're done with calculus. Since we want to solve for dy dx, first let's rewrite this as 6x squared y squared and combine these two into 4x cubed y. move this becomes negative 6x squared y squared on the right. On the left side, we are going to factor dy dx from these two pieces. So take a look. These two, when you take out dy dx, this gives you cosine y, this gives you 4x cubed y. This has moved and is negative on the right side. Divide by the parentheses, and that's dy dx. Find an equation of the tangent line for this relation or function where x e to the power of y plus y e to the power of x equals 1 at 0, comma 1. Recall, when we want to come up with an equation of any line, we need the two things. We need the slope and the pair. The pair is given, so we need the slope. In order to find the slope, we have to differentiate. To differentiate, we are going to go with implicit differentiation. This is the product of x and e to the power of y. And this is using f times g, the product rule. So f prime is 1 times g, which is e to the power of y, plus g prime. Remember, exponential is itself, times y prime. So e to the power of y times y prime, and now times g times f, which is x. So that's this part. So for this part, let me just quickly write it and erase it. For this, maybe I read. So for this part, this is f prime g plus g prime f. Now let me use a different color. For this part, now this is f and this is g. And we are going to use the product rule again. So we need f prime, which makes it y prime or dy dx, times g, which is e to the power of x, plus g prime, the derivative of e to the power of x itself, times f, which is y. The right side is a number, becomes 0. And again, let me put an asterisk next to this. This, everybody, is the only calculus step. You're done with calculus. Everything else is algebra. You're going to finish the job. A quick recap. This is f times g. So f prime is 1 times g, which is e to the power of y. G prime is e to the power of y, y prime, times f, which is x. Again, this is fg. The derivative of y is y prime times g, which is e to the power of x. G prime is itself e to the power of x times f, which is y. The right side is a number, and we're done with that. So what do we do now? Let me erase my work again. First and foremost, if you plug in, it will give you the slope, but you really have to solve for y. So what do you do? These two pieces remain, and these two pieces move to the right. So this becomes negative e to the power of y. This becomes negative e to the power of xy, or you put a negative in a parenthesis, both of them inside the parenthesis. These two, if you take y prime out, this one gives you e to the power of y times x. This one, it just gives you e to the power of x. So that's this factoring, everybody. So what is y prime? Is the right side. Notice the right side, we have a negative sign in front of it. The right side divided by the parentheses e to the power yx plus e to the power of x. So what is the slope? Evaluate this when x is 0, y is 1. So you write m is y prime such that 0, 1, meaning replace the x with 0, y with 1. Let's do that. So e to the power of 1 or y plus e to the power of 0 times 1, e to the power of y times 0 plus e to the power of x. So what happens here? Let's just make sure we understand it. First and foremost, e to the power of 0 is 1. So the numerator is e plus 1. And this is 0 because 0 times e to the power of 1 makes it 0. E to the power of 0 is 1. So you have this negative sign, which is not going to go away. E plus 1 over 1, which means simply minus e minus 1. Now, we are going to use the easy way out. We are going to use y equals mx plus b because b is given. This is your y-intercept, everybody. So b is given. So y equals m, just the way it is, exact answer, in a parentheses times x plus b, which is 1. And you leave it like that because the coefficient of x represents the slope, and this is an exact answer. Don't change it to 2.718 because that's an approximation, and we are done.